Let's solve using the integer rules. For the same sign rule, we'll highlight it green, and for the mixed sign rule, we'll highlight it yellow. Problem number 1 is a same sign problem because you have -4 plus -3. They're both negative and they're both the same signs. For problem 2, we actually have a situation where there are neighbors. Anytime you subtract, that's actually the same thing as adding a negative. So we have -3, and we're going to add a -1. From there, you can see that that's a same sign problem. So we'll highlight that one. For problem number 3, we have -5 plus 7. So one's negative, one's positive, and so we're going to highlight that yellow for mixed sign rule. Problem 4 is mixed sign because you have a +6 and we're adding a -7. Okay. For problem 5, we have a set of neighbors right there, so we can rewrite this equation as -2. Double negative turns into a positive, and we're adding 10. Since that's a -2 and we're adding 10, that's going to be a mixed sign rule. And last but not least, we have another set of neighbors right here, so we can rewrite this equation as 1 plus 4. That's a +1, and we're adding 4, so that is also a same sign rule problem. So now that we've color-coded it, green is the same sign rule and yellow is the mixed sign rule, we can just go back and use each set of rules to find the sum. So let's do that. For -4 plus -3, we're going to add the numbers to get 7, and because both numbers are negative, the answer will also be negative. For problem 2, I have a -3 plus -1, so we add the numbers to get 4, and we're going to keep the answer the same sign, which is negative. For problem 3, the mixed sign rule, we're going to subtract the numbers to get 2, and since the absolute value of 7 is larger than the absolute value of -5, we know that the answer will be positive, since 7 is positive. Okay. For problem number 4, we're going to subtract the numbers. The absolute value of -7 is larger than the absolute value of 6, and since 7 is negative, our answer will also be negative. For problem number 5, the absolute value of 10 is larger than the absolute value of -2. So my answer is going to be positive, and we have to subtract the numbers. So my answer is +8. And last but not least, this is just regular addition. 1 plus 4 is equal to 5. For integer multiplication and division, as well as fraction multiplication and division, when you have positives and negatives, the rules are a little bit more simple to follow. Number 7, when you have a +3 and you're multiplying by a -7, your answer is going to be -21. We're just using the rules from the table. For problem 8, -4 times +6 is -24. Okay? Problem number 9, a negative divided by a negative. We know our answer is going to be positive using the rules from the table, and our answer will actually be +7. +15 divided by 3, I'm going to put a little division symbol right there because that's what that fraction bar means, and our answer is 5. Now we have fraction multiplication, which is a little bit more straightforward. The numerator multiplies with the numerator, so 3 times 1 gives me 3. The denominator multiplies with the denominator. 5 times 6 gives me 30. And we also know that a negative multiplied with a negative is positive, so the answer will be positive. Last but not least, we can simplify. 3 divided by itself equals 1, and 30 divided by 3 equals 10. So my final answer is 1/10. For division with fractions, we're going to use a strategy called keep, change, flip. 4/12, we're going to keep that. We're going to change the division to a multiplication, and we're going to flip 8/3 so that the reciprocal is what we're left with, and we have 3/8. From here, multiplication is straightforward. It's literally straightforward. 4 times 3 is 12. 12 times 8 is 96. Now, if we look at this, we know that the greatest common factor of the numerator and denominator is actually 12. So 12 divided by 12 is going to give me 1, and 96 divided by 12 equals 8. There we go. For this set of problems, The only thing that's extra is step 0, and basically if the fractions have unlike denominators, convert them into like fractions, okay? Okay, so we're going to highlight the same sign rule green, and we're going to highlight the mixed sign rule yellow, just like we did at the beginning of the video. If we look at problem 13, it's a negative fraction, and we're adding another negative fraction, so those are the same signs. Okay. Problem number 14, that's a positive fraction. We're adding a negative fraction, so those are mixed. Back to problem number 13, since the denominator of this fraction is 5, both fractions is 5, we're going to keep that denominator the same. Now we're just going to follow the rules. Add up the numerators. 1 plus 3 gives me 4. Because both numbers are negative, then that means that our sum is also negative. For problem 14, it's a positive 3/5, and we're adding a negative 1 over 3. So the denominators are not the same, so we're going to convert them into like fractions, okay? First off, I'm going to circle the denominators, 5 and 3. Then I'm going to multiply. So I got 3 over 3 and 5 over 5. We're going to convert these into like fractions, okay? All right, so I'm going to go 3 times 3. That gives me 9. 5 times 3 gives me 15. Let me erase that so I can clean that up a little bit. So it's 9 over 15. Okay. Now we're adding, so we got 1 times 5 is going to give me 5. 3 times 5 is going to give me 15 again. So now the fractions are like each other. And we must remember that the fraction started out negative. Last but not least, we're going to use step 1 and step 2, just like at the beginning of the video, for mixed sign problems. So first I'm going to subtract my numbers. 9 subtract 5 is 4. Okay, the denominator is going to stay the same. And since 9 has a larger absolute value and it's a positive number, then the answer is going to stay positive. So I have positive 4 over 15.